Hello, everyone. Welcome to the first presentation of the Hazardous Material Transport Outreach Network's 2025 Summer Webinar Series. My name is Kelsey Prihota, and I am the Great Lakes Transportation Extension Educator with Minnesota Sea Grant and the HazMaTON Coordinator. My co-host for today is fellow HazMaTON member Mark Burrows. Mark is a physical scientist with the International Joint Commission. The Hazardous Material Transport Outreach Network, or HazMaTON, is a binational collaborative of specialists from the Great Lakes, Lake Champlain, Hudson River, and St. Lawrence River regions, focused on reducing risks associated with multiple modes of oil and other hazardous materials transportation. Today's webinar is going to provide information on future fuels under consideration by ship owners and operators globally to reduce vessel emissions. As we'll learn today, each of these alternative fuels present challenges for marine casualty responders. Our presenter, Jim Elliott, will share some recommendations to prepare for alternative fuel hazards. So just a few logistics to share with you before we start. This webinar is being recorded, and the recording with captions will be made publicly available on Minnesota Sea Grant's YouTube channel and on HazMaTON's website. We invite you to submit questions, comments, and/or technical challenges at any time via the question and answer box in your Zoom toolbar. You can upvote questions that you're interested in having answered live, and that question and answer session is going to take place right after the presentation. We will send an email to everyone who registered for this webinar with any resources, links, or information that we shared during the event. Mark is going to launch a very brief Zoom poll now, and I'm going to start sharing. And this Zoom poll, just 3 questions, is really meant to help us gather a little bit of feedback that we will use to improve our webinar series in the future. So you will see this poll, and then at the end of our webinar today, you'll also get a really brief 5-question survey for you all to answer. So thank you in advance for your responses to that. So now it's my pleasure to introduce today's presenter, Jim Elliott. Jim Elliott is Chief Operating Officer of the T&T Group of Companies, a retired senior Coast Guard officer, and a past president of the American Salvage Association, managing worldwide marine salvage, firefighting, heavy lift, commercial diving, and emergency response operations. He has 4 decades of leadership experience in maritime operations and has served as an incident commander, salvage master, commercial diver, and project manager on salvage and oil spill response operations from the equator to the Arctic. And Jim holds a Bachelor of Science in Environmental Management from Indiana University, a Master of Environmental Policy from the University of Maryland, a Master of Arts in National Security and Strategic Studies with highest distinction from U.S. Naval War College, and an MBA from the University of Middlesex in London. Additionally, Jim has earned over 75 federal, state, and industry awards and medals, including the U.S. Coast Guard's prestigious Inspirational Leadership Award and induction to the Commercial Diving Hall of Fame. And we're so happy to welcome you today, Jim. And this is Jim's second time presenting as part of this webinar series. So thank you so much, Jim. And you can take it away.
Sure. Thanks, Kelsey. Thanks so much. You can hear me?
Yes, we can hear you and we can see your slides.
Perfect. Well, I really want to thank you for having me here today and having everybody online. The discussion today is on future fuels, the risk response, and some recommendations. To give you some background, you heard about my background. I have about 40 years experience doing emergency response on the water. And I work for a company, T&T Group of Companies. T&T Salvage is our main marine casualty responder, and we were founded in 1957, and we travel the world and do ship salvage from groundings to fires to sinkings. So I deal in this world every day. a lot of people tell me I meet people on their worst days. So, um, in thinking about future fuels, it's important to consider that 80% of all goods, 80+% of all goods are transported via a ship. And we're currently going through a kind of a major transition in the way these ships are propelled. So if you can think about history, in the early 1800s, ships moved from sail to steam. Throughout that period, there were some hybrid ships that had both sail and steam. Similar today, we have ships that have different types of fuels. And then in the 20th century, oil is a primary mover of ships around the world, and that is still today. But with the goal of reducing greenhouse emissions and the International Maritime Organization's goal of going to net zero, ship owners, shipbuilders under a lot of pressure to reduce greenhouse gases, which can include CO2, methane, and other types of um, gases from combustion. All right, so I'm trying to move my slide ahead here. There we go. So today, a presentation for today, I'll talk about the different types of alternative fuels that are being discussed. I'll mention 7 of those, and we'll talk about the unique hazards that they present to emergency responders, marine firefighters, municipal firefighters, ships crews, and port communities. Um, then I'll talk about how we've set up in the US at this point for how responding to a marine casualty from the National Contingency Plan to US specific salvage and marine firefighting regulations. And then finally, I will discuss 6 recommendations on how to improve the state of response in the US. So in the big picture, the majority of what we consider alternative fuel vessels are now propelled by liquefied natural gas. There's about 535 LNG powered ships on the water today with over 500 on order. So when you consider that over 60% of, or the majority of new builds are LNG propelled vessels, this is the kind of the typical kind of alternative fuel threat that we would face. With that said, LNG has been used for over 60 years in the maritime trade with very few significant incidents. So what is liquefied natural gas? It is a liquid that the gas is cooled down to a liquid to minus 260 degrees. So it's a cryogenic hazard, and it's denser, about 600 times denser than the normal gas. So it's for transportation, and that when it's transported, then that gas is off gas is used to propel the vessel often. So responders face cryogenic hazards, which is very unique. So you have to have an additional set of personal protective equipment, and it's can result in like a rapid phase transition from the liquid to a gas and create a flash fire. Can also pose asphyxiation hazards, and if it's entrapped, like a lot of these alternative fuels, it can cause an explosion. So, we in the US, there's ongoing LNG transfer operations. This is just a few photos from my hometown in Galveston, where we're based. This is where they're offloading from trucks to a barge and then to a cruise ship. So a lot of transfer operations are happening on a day-to-day basis. And T&T, our company, we even have LNG emergency transfer systems. So this is probably the most common and refined form of alternative fuel. But with that said, this is considered a transitional fuel because it doesn't meet the net zero goals of greenhouse gas emissions. Another type of fuel is methanol. Maersk one of the largest container ship companies now has a vessel that is propelled by green methanol. So methanol it can easily ignite, pose a unique hazard because the vapor density is heavier than air, so it'll go down into low-lying areas and into confined spaces. It can create explosions. It's also a toxin, and interestingly, it retains its flammability even with a high concentration of water. So 75% water, 25% methanol still can be considered flammable. So these types of ships are already being used in international trade. Here's an example. This is a few shots from a methanol bunkering operation in the Houston area. So electric vessels, while not a fuel, it's a power source for propelling vessels. Mostly smaller vessels like tugboats. This is an example of a battery-propelled tugboat, the Green Diamond, based in Houston. And also, I know most of this audience is from the Great Lakes. These batteries or electric vehicles are being transported, say, over ferries across the lakes. So most people know about these hazards with lithium batteries, but uh, they're multiple. You have a fire hazard, because these batteries can go into a rapid self-ignition called thermal runaway in confined spaces. It produces toxic gases like hydrogen, which can cause an explosion. And these gases are also toxic to responders. And there's been studies, for example, with firefighters that within their PPE, their personal protective equipment, their what's called bunker gear, that these toxic gases absorb into that and continue to cause hazards. And then these batteries may have residual energy. So you're trying to open up a battery bank can be a very hazardous condition for responders. The fires are described as quick, violent, and difficult to extinguish. So these photos are from a ship that our company responded to in Alaska, and it was carrying about 192 of these large banks of lithium batteries for industrial energy use, they're called industrial energy segments. 45 of these broke away in heavy seas, and as you can see from the photos, there was a combustion going on within the cargo holds. It was a very dangerous condition for the crew um, because there was two cargo holds. One of the cargo holds they extinguished with a fixed CO2 system on board. When the other hold caught on fire, all they had was the water from their fire pumps. So we went on board and managed the situation and ultimately helped repack all these damaged batteries and got the vessel safely underway. But it was very pretty intense for a little while as far as the stress level, because we didn't know if it was going to continue to ignite. So these batteries can be very hazardous. There's a lot of new documents out just the past couple of years. Um, the Pipeline Hazardous Materials Safety Administration, PHMSA, has a document out on the hazards involved with damaged, defective, or recalled, called DDR lithium batteries. And Texas A&M recently did a study on the hazards to responders. And even the Coast Guard just earlier this year in April produced a document from the Research and Development Center that discusses the hazards. The concern is once these lithium batteries go into thermal runaway, it's very, very difficult to put them out with standard marine firefighting practices. Another type of alternative fuel is ammonia, which is ammonia has been transported for years for example, fertilizer for the farming industry. but it poses unique hazards. It's very toxic. Death may occur less than 1% by volume. It's flammable. It's very corrosive, um, and it has lower density than air, so it will collect in low-lying areas. Uh, the positive thing with ammonia, I would say, from a greenhouse gas perspective, is that it addresses like ammonia and hydrogen address the concerns with limiting the volume of greenhouse gases. Um, I think China just this month announced that they have have the first demonstration of ammonia powered vessel, and there's others on order. So it's an evolving industry with ammonia fueled vessels. But again, it wouldn't be the first time that we've responded to ammonia. It's just that it'll be in higher volumes because the it doesn't have enough. It's not comparable to like oil with the energy, so you have to have a larger volume of fuel on board or ammonia to propel the vessel. Hydrogen, another type of alternative fuel. This is pretty unique. It displaces oxygen, so it's a suffocation hazard, extremely flammable. So responders have to wear like anti-static PPE, being with most of these in self-contained breathing apparatus. It's extremely flammable and it can explode under pressure. Um, and interestingly, it's difficult to maintain even a small leak from a hydrogen release. So oftentimes it may be better just to allow the leak to burn, as opposed to try to put it out and then have that hydrogen continue to expand and find another ignition source. Nuclear, just this year, the International Maritime Organization stated they're going to relook at the nuclear powered ships requirements and guidance for the commercial industry. So as most of you probably know that nuclear has been around for quite a while, and most of the vessels that are nuclear powered are military vessels like aircraft carriers, submarines, and even icebreakers. So the Russians have several nuclear powered icebreakers, and the French Navy, for example, has a nuclear powered aircraft carrier. The photo at the top was the US's one of the only nuclear powered commercial vessels. It was built uh, around 1958, deactivated in 1971. So there's a lot of issues with nuclear. You probably won't see this on the Great Lakes anytime soon, but it would pose a whole different set of emergency response standards, different types of organizations that are not typically found in a unified command for a vessel, which would be typically the Coast Guard and the state involved. It would involve the Department of Energy, Nuclear Regulatory Commission, and others. And the responders, like the ship's crew, would have to have specialized training in nuclear response. The picture at the bottom is a company called Crowley has proposed developing a microreactor to generate energy for emergency response. Finally, biofuel. Biofuels are fuels made from plant and animal material. For example, soybean oil or waste cooking oil. And in talking to the Great Lakes industry, this would be probably the most likely initial alternative fuel used in the Great Lakes. And while it doesn't completely reduce greenhouse gases, it will reduce that. So it would be a way to reduce the volume that's produced, but even biofuels have unique characteristics from fire, reactivity, and toxicity. A lot of times you will see these fuels blended with normal or typical oils to reduce the volume of greenhouse gas. In the Great Lakes, if you're interested in 2024, March of 2024, there was a study produced for the feasibility of future energy options for Great Lakes shipping. It noted that the majority of greenhouse gases in the Great Lakes from the maritime industry is produced by the bulk carriers, as you can imagine, and then about roughly 30% is produced by the tugs. I mean, moving cargo around the Great Lakes is a big industry. It employs a lot of people, and it's something that will be looked at moving forward. So it's already under discussion. So with that, with the discussion of the unique hazards posed by proposed alternative fuels, and I want to just briefly discuss how marine casualty response works in the U.S. today. You can read these quotes. These quotes are from the National Contingency Plan, which is 40 CFR 300, and kind of lays the foundational concepts for response. That says that safety of life is always the top priority during every response action. And after that, the goal is to stabilize the situation to prevent it from getting worse, whether it's a fire, grounding, collision. And then defensive actions shall begin as soon as possible to prevent uh, impacts to public health or welfare and minimize impact to the environment. So it was mentioned that I serve in the Coast Guard, served for 26 years. These were my guiding principles throughout. Now that I'm in the salvage industry, same rules apply, right? And I think this should be the overall objective for any response is to save lives, prevent the loss of life, and then stabilize the situation. So interestingly, in the U.S., in around 2008, the U.S. Coast Guard published salvage and marine firefighting regulations. And the applicability for these regulations are simply Group 1 through 4 oils. Group 1 being the lighter oils like aviation fuel. Group 4 being your heavier oil, bunker oil that you would typically find propelling these large ocean-going vessels. Interestingly, it didn't include Group 5 oils, which are that can sink, have a specific gravity greater than 1, such as asphalt or even heavy oils can mix with sand and sink. Or in the Great Lakes, for example, if it's very cold, the oils can sink. So every tank vessel and even non-tank vessels need to have a vessel response plan. And these vessel response plans bring together a group of specialized teams that respond. So for typically when there's marine casualty, there's an oil spill removal organization that's there to address any type of release of oil, and the salvage marine firefighting service provider that responds to ideally move oil cargo from a damaged tank to minimize the impact, put out a fire, refloat a vessel. And then for larger incidents, there's an incident management teams that help manage the entire operation and produce incident action plans, working within a unified command. So when you think about the way we're set up, it's set up for traditional oils. So one thing to take away from this is that you need specialized training in each of these unique hazards to respond to these types of incidents. So there's a lot of education and training that needs to take place as a new alternative fuel vessel comes into a port. This shows the difference between the way salvage traditionally worked and the way it works under the current guidelines under the U.S. regulations where you have a vessel response plan. Historically, an incident would happen and the owner would go out for a bid to try to find the best financial value to salve the ship. This often delayed response actions, and the impetus for the salvage marine firefighting regulations was that you would have a contract already in place so that you would minimize the delay and you could immediately respond. So, for example, if an incident happens in the Great Lakes with the Great Lakes carrier, there's a salvage and firefighting service provider named on the vessel response plan, and they can immediately respond to the incident. The issue with alternative fuels is because the applicability is only for Group 1 through 4 oils, there's a question to where these alternative fuel vessels would fall into this response framework. I'm just going to show you a visual of the way the salvage and firefighting regulations are set up. You can see 19 services that are required, from remote consultation to towage to diving to lightering, which is removing the oil from the vessel. And so, for example, in the Great Lakes, you can see your timelines there. These are planning timelines that the owner operator and the service provider, salvage marine firefighting service provider, have to show to the Coast Guard that they can meet these goals in the hours to respond. So just one example, for emergency lightering within 18 hours, we should have all the equipment to pump off the largest oil cargo tank from the vessel. Firefighting, our standards are much more stringent, and I know Kelsey is going to provide you some documents afterwards, and I'd be happy to share these regulations with you, and you can call me anytime if you have any specific questions about that. And I know there's going to be some question time in just a few minutes. So with that, I'm just going to discuss six recommendations based on my experience and my both in the Coast Guard and now as a contractor to respond to marine casualties. First lesson is a recommendation is emergency responders and the salvage industry should be involved in the maritime industry's safety by design process. And the concept of safety by design incorporates the prevention of health and safety impacts into the design and construction of the vessel. So my experience with alternative fuel vessels is that they come into a port, and then we go on board to evaluate how we would respond. And we always have a lot of recommendations on how to improve how that could happen based on our experience. And I think it would be great if responders were included in that, to kind of begin with the end in mind concept. Within the Coast Guard, there's in marine safety, there's two primary groups. There's prevention and response. And the prevention folks are doing plan review for new construction of vessels and giving regulatory interpretation for design. And then the responders, the response side, responds when things don't go as planned. So my goal would be to bring those together from the first concept to build a new alternative fuel vessel. The next is obviously responders must be properly trained, equipped, and prepared to respond to alternative fuel vessels. In July 2023, two firefighters lost their lives in Newark, New Jersey, on board a roll-on, roll-off ship fire. I mean, it was very tragic, and it obviously should have been prevented with training and understanding of how ship response works and ship design. There was an NTSB report and identified that the firefighters weren't properly trained or equipped to respond. So this is just a oil propelled vessel, unique hazards on board with every type of ship, but this was a roll-on, roll-off ship where cars are transported. So large areas, lengthier response times. So ideally, both Coast Guard, state, and local responders would have some understanding of how to respond to these unique hazards. I'll give you one example. The photos I showed of the liquefied natural gas bunkering operation. part of that process to approve that operation was to do a waterway suitability assessment. And in doing that, we brought all the stakeholders together. The U.S. Coast Guard was a lead, and to find gaps in how we would respond, or how, any issues with the operation. One of those findings was that the municipal firefighters didn't have training in how to respond to liquefied natural gas. So part of that process for the approval was to ensure that they had the proper training to respond. The next recommendation is national and area contingency plans should include response procedures for alternative fuel vessels. I think whenever a new type of vessel enters a port, these plans should be updated to address those unique hazards, and also do an assessment, for example, the waterway suitability assessment on how the community would respond. Over the past couple of years, I've been a part of a national salvage and marine firefighting work group with the Coast Guard, and they currently have a draft marine firefighting guidelines for ports. And one of my goals was to include alternative fueled vessels in this national guidance. Fourth recommendation is government agencies, ports, municipal firefighters, and the maritime industry should work together to conduct those risk assessments, gap analysis, and develop tactical response plans. I do a lot of exercises with port communities around the U.S., and typically these are tabletop exercises. So equipment is not deployed. It's good to get everybody together to understand everybody's roles and responsibilities, but I would argue that the need is for tactical response plans on how firefighters would actually respond on board a vessel, and how we would integrate into a unified command with municipal, industrial, and commercial firefighters. And fifth, the salvage and marine firefighting regulations should be revised to apply to alternative fuel vessels. I'm certainly biased as a marine salver, but I think all vessels should have a plan in place for an emergency, not just those carrying Group 1 through 4 oils, but every vessel that is on the waterway, because salvage is time critical. Things often don't get better with time. So having those plans and contracts and all of that set in place from the beginning will only save lives and protect the environment. And then finally, legal frameworks need to address alternative fuel vessels. So for example, most oil vessels propelled by oil or carrying oil have to have certificates of financial responsibility. The concept is the polluter pays. So they have to have insurance, basically, to say that they have sufficient funds to respond to a worst case discharge. And I would argue that the same should apply for alternative fuel vessels. And finally, I'll leave you with a quote. Something to think about is that in initial response, there's a lot of unknowns. Typically the response happens in the middle of the night. You don't have all the information, and there's unique challenges to each one of those. So since at the moment that an emergency response is required, there is no time for extensive research. I like this quote. There's an old saying that you should never exchange business cards in the middle of the night during an emergency response. This is it. And I'm trying to do my own research. I have my own interest in this. But the time for extensive research isn't when an emergency is happening. It's beforehand, so that we're all prepared to respond. So with that, I think I've met my 30-minute timeline. I look forward to your questions.
Thanks, Jim. That was an excellent presentation. I really appreciate it. We've got a couple of questions here, and I will I'll take them as they were put into the Q&A thing. Um, this one's from Geneva. It's what's it like on the inside of a salvage company that needs to be ready for rapid emergency response? Is there a large pool of employees on standby, ready to deploy to incidents in a given radius?
Great question. Thanks for that question. Yeah, it's a great group of people that have unique experiences doing marine casualty response. So, for example, we have a entire organization filled with master mariners, salvage masters, folks that understand how to move oil cargo, pump it from molasses to aviation fuel, divers, hydrographic surveyors, um, crane operators. So, a pretty cool group of people, and always, yeah, always on standby to respond around the world. So, uh, in addition to core groups, and I'll just speak for our company, and core groups in the U.S., and so we have a group in Houston, Galveston area, and then a core group in the Great Lakes in the U.S., and then we have personnel all around the U.S. To respond in every coastal state with pre-positioned equipment, so that I showed you the salvage marine firefighting regulations. There's timelines. We have to have equipment that can readily respond throughout the U.S. And then worldwide, we have office in Singapore, the UK, Peru, other locations. So we are currently, for example, we're currently on a grounded ship in Newfoundland, Canada. We're on a marine fire fighting operation off the coast of India, and just finished a job on the Great Lakes myself. So we're working around the world. It's I always joke around that I don't have any hair and I'm 4 foot tall now after doing this for so long. It can be very stressful. You're on call 24 hours a day, so you can get a call in the middle of the night and you have to immediately wake up and become alert and guide whoever's calling you through the initial phases of emergency response, and then mobilize equipment immediately. So one final note, we have to be experts in logistics. So we have to be able to move equipment and personnel quickly around the world. And that can be very demanding also. So we maintain contracts with just about every towing company, multiple diving companies around the world. And we work with our competitors and our partners to respond. So yeah, thanks for the question.
Well, thanks, Jim. The next question is a little bit technical, but it's it's a question about regulations and the requirement for a vessel response plan. Do they still have to have a specific response requirement to a worst case scenario on the vessel? And how does this apply to new risks with alternative fuels?
Sure. I mean that's one of the main points in my discussion is um, so first off, in the US, vessels carrying Group 1 through 4 oil that I mentioned are required to have a vessel response plan. On that vessel response plan, you have a qualified individual. That's a designated person for the company that can basically call out the other contractors, the oil spill removal organization, and the salvage and firefighting service provider, and other contractors if needed to handle the situation. So they're empowered to spend money for for the company. If anybody's interested in taking a qualified individual course, I can set you up with that. But um, out of that, it's interesting. The U.S. is the only one that has specific salvage firefighting regulations, and I showed you those timelines. On the oil spill removal organization side, there is OSRO guidelines, and I can send those to share with everybody. And it gives you, depending on the quantity of oil, how you would respond to, most probable, worst case scenario, those types of events. And those vessel response planners are reviewed by the U.S. Coast Guard, and ideally they're exercised on a regular basis, depending on the type of vessel. So my concern, with my experience in the Coast Guard and my current position managing a salvage and firefighting company, is that it appears that there may be a gap currently as we make this transition from oil-fueled vessels to alternative fuel or future-fueled vessels, that the regulations may not apply. And how do you make that link? And how do you make the link for certificate of financial responsibility? So I've met with the Coast Guard as a member of the American Salvage Association. The discussions are ongoing, but we'll see how it turns out with that. My concern is that it seems that I used to be a Coast Guard inspector, and my saying was these regulations are often written in blood. Regulations aren't made until an accident happens and someone loses their life. So ideally, you would be preventative and you would think about the hazards and have standards or regulations in place to address them ahead of time. I hope that answers your question.
Uh, Thanks, Jim. I'm going to lump the next couple of questions together. They're about the similarities or dissimilarities of regulations between Canadian vessels on the Great Lakes and response preparedness and that sort of thing. Do they have similar requirements for pollution response plans? And I would add, does the International Maritime Organization have anything in the works to kind of generalize requirements for port safety purposes and that sort of thing?
Sure. Thanks for that question. That's a big question. So, so I would say the Canadian government certainly has similar types of rules for oil spill response, and there's an agreement between Canada and the U.S., and it's exercised on a regular basis. For example, I believe in September there's an exercise that I'm scheduled to go to that's going to address salvage and oil spill response on a Canadian border. I was just involved in a incident on Lake Superior, and the Canadian government was involved with U.S. Coast Guard, involved in managing that operation. So various, I would say they're pretty much aligned when it comes to the goal of minimizing environmental impact and responding to oil spills. I don't believe the Canadian government has salvage and marine firefighting specific regulations like the US. My understanding is the US is the only country in the world that has these. So it may be the case that, you know, that a contract would have to be taken at the time of the incident, as opposed to currently in the US, where you have a contractor already named on that vessel response plan. I mean, the IMO certainly has standards for, and they're continuing to evolve with the alternative fuels. But within the U.S., it's the Oil Pollution Act of 1990, National Contingency Plan are the two, I guess, the two primary documents. And then there's guidelines from the Coast Guard and other organizations on specific requirements on how you meet those standards.
Well, thank you. One question I have is, recognizing that the Coast Guard requires plan approval for new commercial vessels and including engineering plan approval, how well have the industrial standards for, say, like ammonia or hydrogen or one of these other alternative fuels evolved to keep pace with the maritime industry? Can they get their plans approved in a quick manner, and are there adequate standards currently?
Sure. So I'm certainly not an expert in that regard. My understanding is yes, the Coast Guard, the Marine Safety Center, the team of naval architects and experts there, they review a new build on a case-by-case basis, and they are getting approval for different types of fueled vessels, is my understanding. It's we have one thing that we haven't talked about is the role of classification societies. So, for example, American Bureau of Shipping and other classification societies have standards, and I I would argue they probably have the most thorough understanding and guidance on new builds of different types of alternative vessels. The Coast Guard works closely with classification societies, and yeah, to answer your question, yes. I mean, there's a process in place to do that, and there's a team at the Marine Safety Center with the Coast Guard headquarters that would review those plans.
Oh, thank you. I don't have any further questions in the Q&A box. Looking at the chat. Kelsey's reminded everyone there's time for a few more questions. We've got about coming up on 10 minutes remaining. Um, I really appreciate it. I wanted to point out that the smaller vessels, the Great Lakes has about 100 research and academic vessels on there, and they've made quite a lot of progress in converting over to biofuels
Good.
over the years. The one thing that seems to be a hang up is that for some fuels like LNG and that um, the dockside facilities are kind of hard to come by, so they tend to be only available in certain areas. And I was wondering if you've seen much progress on the availability of this, and is that a holdup for more people adopting alternative fuels?
Yeah, certainly. I think the infrastructure has to support the maritime transportation industry. So, for example, you know, the example I would use is electric vehicles, right? You have to have that infrastructure in place. If you're going on a long trip, you need to be able to charge your vehicle on a regular basis. Same applies to maritime transportation, regardless of the fuel. You need to have you need to have the feedstock. You need to have the infrastructure in place to support that type of fuel. So that can, the economics of world trade is going to be a driver on how, which alternative fuel wins. And part of that is going to be the infrastructure in place. I mean, currently liquefied natural gas on the world stage is the dominant alternative fuel. And it's been proven for, in transport for over 60 years. So um, I, I I think that's what you're alluding to, and you certainly have to have the infrastructure in place. And in talking to, the maritime industry in the Great Lakes, when we're talking about biofuels, is that issue also? How do you get the quality of the feedstock, um, and how you maintain that, um, and have the infrastructure in place to support it?
Thanks. We've got another question here in the Q&A box. It says, since responding to alternative fuels is a relatively new concept, how do you incorporate real-time learning during a complex response operation when the problem is new or unique and, it's not oil or hydrocarbon fuels? Because that's kind of a tough question.
Well, I would say, the typical oil spill removal organization, OSRO, are designed for recovering oil in the water with skimmers and storage capacity and sorbent materials, those types of things. And our industry, salvage industry, is typically designed for pumping oil. We have hydraulic power units and hoses and pumps, hydraulic submersible pumps, all those types of things. We're set for that. These types of hazards, my are fast, and they're fast responses. They're often hazardous materials or hazardous substance responses. So it often requires a new skill set. Everybody needs to be trained in how to use a self-contained breathing apparatus, infrared cameras, how to protect themselves, when to decide not to go on board a vessel. That's often people don't want to hear that, but there may be a time where you don't go on board a vessel that's getting ready to explode, those types of things. So it's a different skill set. And that was one of my recommendations is with these new vessels, if you're in a port that has a future fueled or alternative fuel vessel, know those hazards, know the personal protective equipment that you need to respond, and what responders will do that. I wrote a paper on this. One of my recommendations was to have what's called a task force model, because everybody's not an expert at everything, but you find that team that, kind of like the salvage industry, we bring together different types of skill sets to solve a complex problem. I would say that's what you would need in the port. Collecting that information on what lessons were learned and sending that out. A lot of that is, my experience in the Coast Guard is through investigations, like the NTSB will send out reports. The Coast Guard just yesterday sent out a notice, a safety alert on lithium battery storage banks. So that's how, there's a couple of ways that lessons are communicated to the industry.
Thank you. I was wondering, in the Great Lakes, there's like well over 6,000 sunken wrecks. Do you often get involved in recovery of oil and hazardous chemicals from submerged vessels? I was thinking of just a few years ago, there was a sunken barge on the Canadian-US border that had some really nasty fuel. Well, it was an oil mixed with
There's benzone.
hazardous chemical, and those wrecks are only getting older. And I imagine that sooner or later, some of the submerged oil will need to be removed, and it's not always oil, So
So you're
are
talking
those
about my
becoming more
favorite
common?
subject. Yeah, this is my favorite subject. It's sucking wrecks and recovering oil and other hazard materials. So I was actually managing the project. It's called the Argo. It was a barge
Oh
that's
yeah.
built in 1919, sank in 1937, had a high benzene cargo. It was in 55 feet of water in Lake Erie,
Mhm.
and it started leaking, and it was creating an immediately dangerous life and health atmosphere as it would leak. So our company went in and what we call hot tapped. We put divers down, tapped into the hole, and pumped out this. It was a very high benzene cargo. It was a really interesting job. I know we don't have enough time to talk about it, but there's a NOAA study, I think it was dated 2013, remediation of underwater legacy environmental threats, roulette study that mapped out or did a risk assessment of sunken vessels around the US and the Great Lakes. And the Argo was one, that barge that you mentioned was one of those listed in that study. Uh, there's others. There's a ship right off of Milwaukee that's a recreational dive site that's listed on that study. That wreck probably still contains oil. So you could do a whole webinar just on this topic.
Oh, thank you. I was really paying a lot of attention to that Argo response when I heard someone mention that the product was so hazardous that it actually melted somebody's gloves. So I thought, well, that's got to be a pretty complicated response operation there. So I'm sorry we don't have more time for stories like that, but it's a really good learning experience, and I appreciate your thoughts and everything. I'm gonna turn back to Kelsey here, and maybe we can wrap things up.
Yeah, thank you so much, Jim, for sharing all of your expertise with us today.